Question 14, wave-particle duality and the de Broglie wavelength equation. Right, an optical microscope uses a beam of visible light. An electron microscope uses a beam of electrons. Okay, right, biologist. It's getting all biology on us now. Right, we have a biologist. Looked at an animal cell using both microscopes. The two images are shown. Okay, I must admit I'm not bowled over by the image from the electron microscope, but you can kind of see a bit more detail, but I thought they could have done a bit better here. Anyway, right, an electron beam of the electron microscope has a velocity 2% speed of light. Calculate the de Broglie wavelength of the electron. Okay, what's the equation for the de Broglie wavelength? Right, the de Broglie wavelength. So basically, even particles, all particles have a wavelength. Particles that are moving have a wavelength. And the wavelength is Planck constant over p, which is momentum, remember. So that's h over mv. Now, if you can remember what h is, we should know this from all our practicals we've done during distance learning, but that's 6.63 times 10 to the minus 34 joule seconds. It's a tiny number, okay, because the quantum world is tiny. Right, velocity. How fast are these electrons traveling? Right, we have, okay, so basically the electrons are traveling at 2% the speed of light, which is 6 times 6, 6 times 10 to the power of 6 meters a second, okay? Mass of an electron. All electrons have the same mass. It's in the back of your book. This is data that's given to you in any exam. This is data that I can't remember. This is data that's given to you in any exam. So yeah, 10 to the minus 31. Electrons are tiny. Kilograms. Substituting into the values. So substituting the values into the de Broglie wavelength equation gives us a lambda of 1.21 times 10 to the minus 10 meters. Okay, right. You're not asked to do this, but I want us to think, how many nanometers is that? Okay, how many nano? Nano's 10 to the minus 9, isn't it? Okay, nano's 10 to the minus 9. So this is 12.1 times 10 to the minus 9 meters, or this is 12.1 nanometers. Would we agree? Okay. What reason I've done that? You're not asked to do that. The reason I've done that is because this shows us why electron microscopes are better at resolving detail than optical microscopes. But what do optical microscopes use? They use visible light. What sort of wavelengths is visible light? Okay, what's the range? These are numbers that you should know off by heart. Right, visible light. The range of wavelengths in visible light go from short wavelengths, nanometers, 400 nanometers, up to, what's the top end? It's 700 nanometers. Now, why have I done that in purple and red? Well, red is the longer wavelength, so red light goes up to 700 nanometers. Violet light at the other end of the visible spectrum is 400 nanometers. Okay? These electrons we're using have a de Broglie wavelength of 12.1 nanometers. Yeah, considerably shorter than the shorter wavelength in the visible spectrum. Can we see that? So if you use waves that are of a shorter wavelength, they're going to be much better at resolving detail. Okay. Now, I want you to just explain why. Why is this the case? Well, the reason is because of diffraction, or in particular, the lack of diffraction. The shorter the wavelength, the less diffraction happens when the wave encounters things around about the same size. Yeah, if we're trying to resolve the detail in things that are very small, okay, because visible light has a longer wavelength, it's more likely to be diffracted by the fine detail within the thing we're looking at. If we use things, waves, in this case electrons, with a wavelength, with a shorter wavelength, they're less likely to be diffracted by the fine detail within the thing we're looking at. So that's why electrons are actually much better at seeing, in inverted commas, the fine detail in the microscopic world. Okay. And finally, part C. I was absolutely gobsmacked by this question. To me, this is a GCSE biology question. What on earth it's doing on an AS physics paper is anyone's guess. Anyway, right. So the biologists measure the diameter of a cell. They've got it on 800 mag. Determine the value of the diameter. We're given 4 values. One is clearly an anomaly. So we take this, this, and this, and we find a mean. Okay. So the mean diameter 2.4, 2.5, 2.2, 2.4, isn't it? 2.4 centimeters. Okay, we've got on 800 times. Okay, so it's 2.4 centimeters divided by 800. In reality, it's 0.00003 meters. Okay. Just change that centimeters to meters there. Right. Not sure you're going to see an easier question in A-level physics than that, to be honest. Anyway, right. See you in the next section.